This lesson is on transformation of functions, and the goal is to analyze transformation of functions. What you should understand by the end of the lesson is there are sets of functions called families, in which each function is a transformation of a special function called the parent. A parent function is the simplest form in a set of functions that form a family. You're going to look at some parent functions and look at some transformations. All right, here is what we are talking about when we're talking about a parent function and transformations and how to do it. This would be f of x, or the parent function. The red in the middle here is also a parent function. Now, a transformation, in this case, would be translations. If we wanted to move this parent function up, we would add a number after it. If I want to move it down, I would subtract a number. So if this was just saying a line, and this was is going to be y equals 0, this would be y plus 2, and this would be y equals negative 2. All right, so you're just adding to bring it up or subtracting to bring it down. On this function, we're moving it left or right. Notice we're taking the x and subtracting to move it right, or we're taking the x and adding to it to subtract to make it move left. And it's almost the opposite. Some of you are going to miss this, and I know I sometimes have trouble wanting to add to move it up the line, and in all reality you're going to subtract. And you're going to want to subtract when you're moving it to a negative number, but you're going to add to the x value. So we're going to take a look at some examples so you'll know how to do this. These are the important things that you need to know about how to translate. Again, if you have y equals a function and you want to move it up, you add to the function. And if you want to move it down, notice it has to be greater than 0. If k is greater than 0, then you're going to subtract that number. Again, if you want to translate it left or right, h units, h has to be greater than 0. To translate it to the right, you subtract. To translate it to the left, you add. Now you can also stretch and compress, such as an x squared or an absolute value. And if you want to stretch it by an amount of a, where a is greater than 1, you just put that in front of the function. And if you want to compress it, then your a has to be a fraction, or somewhere between 0 and 1. It cannot be a negative number. All right, and then if we are reflecting, and we're reflecting in the x-axis or across the x-axis, so we are flipping it up or down, we are going to make it the opposite of the function. And if we are moving or flipping it in the y-axis or left to right, we are going to make it the opposite of the x value. Okay, so there's a difference between the opposite of the function and an opposite of the x value. All right, here is your parent function, y, or f of x, equals the absolute value of x. Notice the vertex is at the origin, and your axis of symmetry, that's where we cut it exactly in half, is your y-axis. So that is what the parent function y equals the absolute value of x looks like. The next, we're going to look at how we change or how we transform that function. So we've got, again, it's pretty much the same as the last, as when we looked at any of the other transformations. You just take to move it up or down. If it's greater than 0, you add to move it up. You subtract that number to move it down. Again, you put to move it left or right. Where h is greater than 0, you put the minus h inside the absolute value to move it to the right. You put plus h inside the absolute value to move it to the left. Again, with the vertical stretch, you put a on the outside of the absolute value. Your vertical compression, which makes it thinner, must be a fraction, and you put it on the outside of the absolute value. To reflect over the x-axis, or up or down, we put our the minus or the opposite of whatever it is outside the absolute value. To flip our function left or right, or reflect across the y-axis, we put the minus sign inside or the negative sign inside the absolute value symbols. So I know this sounds rather difficult again. We're going to look at several problems on how to do this. Here is our first problem. We're asked to find g of x, where g of x is the translation 2 units right of f of x, 3x minus 6. Now go back to your notes, and if you look at it, you're going to see that to move it to the right, you take the function, and then it's x minus h, where h is greater than 0. So I replace my x with x minus 2 because I want to move it 2 units right. So I'm going to do 3 times x minus 2, and then I have the minus 6. I'm going to use the distributive property, and I have 3x. 3 times negative 2 is negative 6 minus 6. I can only add my numbers together, so I end up with 3x, negative 6, and negative 6 is negative 12. So g of x is 3x minus 12, or that answer right there. So what you're doing is you are replacing x with either x minus h or x plus h, doing the distributive property, and then adding any other number that is still there. Here's your first practice problem. You are to find g of x, where g of x is the translation 3 units to the right of f of x equals 6x plus 7. Do practice problem 1 and follow how I did my practice problem. In this one, they want us to find g of x, where it is translated 2 units left and 10 units down. Well, 2 units left is going to be f of x plus h, and then we would, to move it down, we subtract k. So they want us to move it 2 units left, and they want us to move it 10 down. So that's what I'm going to do. I'm going to take the f of x and insert these numbers. So here's how we do it. We go 7 times x plus 2. We still have the minus 10, and we're going to do another negative 10. So now I'm going to do the distributive property. So 7x, 7 times x is 7x. 7 times 2 is positive 14. I still have these two negative 10s. I combine only my numbers. So I have a negative 10 and a negative 10, which is negative 20. And when I add 14, I get negative 6. So I end up with 7x minus 6. So 7x minus 6 is g of x. Here's your practice 2. Find g of x, where g of x is the translation 1 unit left of f of x equals 6 times the difference of x minus 2 squared plus 10. Number 3, they want you to write the equation of g of x, where it is the translation of 5 units up of f of x equals negative 8 times the absolute value of x minus 4 minus 1. All right, here is a parabola, or the parent function of x, f of x equals x squared. And they want us to write the function rule for this one. So I know that my vertex for the x squared is right here at 0, 0. So I just need to find how far over it moved to the left and how far up it moved. So it moved over 8 units to the left, and then it moved up to 3, so it moved up 3 units. So I'm going to take my parent unit, x squared, and I know that when I move it, I subtract. So I have x minus 8 squared, and then I'm adding 3 because I moved it up 3. So this is g of x, or the new equation of the parent function x squared. It is x minus 8 squared, then plus 3. Here's your practice 4. You are going to write the equation of g of x of this graph. However, yours moved to the right, and it also moved down. This one asks us to find g of x, where g of x is the reflection across the x-axis of f of x equals negative x plus 6. And I'm going to write that equation. Well, if I'm flipping it across, then I am doing my negative sign is going on the outside. It is the opposite of the f of x. So all I'm doing is changing the sign of everything. So g of x becomes the opposite of those. So I'm going to have x minus 6. If I were doing this across the y-axis, where it is shows that when it looks like this, then I would have had a different, all I would have done was change the sign of the x and not the 6. But because this is the way it looks, I have to do the opposite of the function, or take the opposite of, to change the sign of everything in the function. This one says I just take the opposite of the x value. Your practice 5 is to find g of x, where g of x is the reflection across the x-axis of the function, the opposite of the absolute value of x minus 3 plus 10. This question asks us to find g of x, where it is a reflection across the y-axis of the function 5 times the sum of the absolute value x plus 8 minus 9. So again, when we reflect across the y-axis of an absolute value, the absolute, or the negative sign went inside the absolute value sign. So I'm just going to change the sign of the number of that's inside with the x. So I don't change any of the outside numbers. So I have 5 times the difference of x minus 8 minus 9. So notice when I'm doing a reflection across the y-axis, I only change the sign of the number. And your practice 6 is to find g of x, where it is the reflection across the y-axis of the function negative 5 times the absolute value sum of x plus 10 plus 7. After you're done with your 6 practice problems, bring them to me for grading before you start on your IXL lesson. You must make a 90 or better on your IXL lesson before you can get a grade, and then you will put where you were on your IXL lesson at the end of the day at 1 beginning, 2 learning, 3 understanding, or 4 expert. And from all of us in the function family, have a wonderful day.